Hello. We're gonna pick up kind of where I left off. I don't actually know where I left off exactly. We were talking about Chinook Trough here, Emperor Trough, which at some point I called Mariana Trench, but I meant Emperor Trough. Hess Rise, there's Kamchatka is related. The idea is that Kamchatka formed atop Hess Rise. Maybe we can open one of this. Dear computer. Okay. This was my attempt to capture possibility. But where Kamchatka was down here. I guess I didn't open it. Pause. It's okay. I'm not sure if I saved whatever I'm looking for, but where the concept is I guess I see my last video, so this makes some sense. In Underground Science, the documentary Riding the Vortex, which takes a while, but it makes sense in the end. As to why I'm talking about that in regard to this, it starts with shallograms. It's like, what the hell are you talking about? How is this related? It is related. So the sphere of Hawaii runs into Kamchatka and Hess Rise and causes northward motion of Kamchatka, which goes up to generally here, so that it's like this here, relating to this pressure point as relating to this pressure point, and then from there it moves out and over to where it's at over here. And as it's doing that, this moves out and over to over here. Okay, so that's the idea, and we're gonna go through some stuff. Before I do that, I just thought I'd show this. Let's see, give it a stroke. Oh, that didn't help. Stroke. Make it maybe 3, 4. There we go. I just thought eyeball, like a mouth, nose area, like a head of a dragon, and then like scales and stuff, and then a wing off that way. If we look at it here, I just thought it was interesting. So let's share it. Here's the head, here's the nostrils, the mouth underneath it, maybe not the most defined. Like the bridge of the nose area, maybe one of the eyes is over. The right eye on the left side is not as distinct as the left eye. And then like an ear looking thing, and then kind of a repeat. It almost looks like a dragon on the back of the dragon at some point, but I don't see it now. But then where the wing goes off this way, and even has like a protruding bone. Dragon images, I guess, like that, like how those are. Like how mostly dragons tend to be depicted, having this thing here. Even with like a web section where it continues, possibly in some element continuing down into South America, but at least through Central America, as like a wing of this dragon, where its head is over here, and then its shoulders here of like an arm, but then the wing even has a like joint of this eddy center, and then where the other wing is kind of going off this way. Maybe to over down here. Okay, just a fun idea. Anyway, not really crucial or anything, but relating to some other things we've talked about before. So, I've been thinking about this, and I did this. So let's go through this one. Remove the layers. Move all the layers. So we've got Eastern Pacific and North America, especially here. But the Eastern Pacific formed later. So if we go Oceanic Crustal Age map, images. So here, this region is, according to interpretation, about 100 to 180 million years radiometric dating. Whereas the region near North America, the Americas, is more in the range of 0 to, let's say, 60, 80 maybe, at the more so towards 60 even. Like KT boundary time frame, 0 to KT boundary in the tertiary. Yeah, basically tertiary, which also to present. So that this region formed while this region pre-existed and was over here though. So it was actually being shoved out as it formed. Like this. So we had Western Pacific with the Mid-Pacific Mountains relating to North America like that, where the Mid-Pacific Mountains were forming, abutting the resistance here. And then there was resistance here, which I believe was Shatsky Rise generally getting pushed out. So I'm not sure if drill samples have really confirmed that these are all like the same time that the whole length formed of each one. They certainly don't have that many drill samples. There might be some that are along their length. I'm suspecting that there's some elongation here that's not really captured in the details, because Shatsky Rise, in my interpretation, was the backstop here that's not at the front of the Mid-Pacific Mountains. Here's the Mid-Pacific Mountains. So this region was forming, abutting the underplate, basically, of North America here. Abutting this. But then over here, down to about here, in this area, was the front of the Mid-Pacific Mountains, where over here isn't a backstop because it's missing. And mind you, where is the Shatsky conjugate? Shatsky conjugate beneath Western North America, approximately 90 to 70 MA, from Southern California under the Colorado Plateau into Wyoming. So it traveled, according to this. Let's actually find a paper, I guess. Shatsky conjugate. I'll even pause for a second. Okay, that was fast enough, this one. The role of oceanic plateau subduction in the Laramide orogeny. So we have Shatsky conjugate here that then is basically going underneath North America at around the United States, Mexico margin area. Let's just make sure. S, Shatsky conjugate plateaus. And then H is Hess rise. So I guess Hess rise also has a conjugate under North America. So the idea is, it's not that it was like subducted as they say, it's more so that it was there and the rest of it moved out away like this. So Shatsky rise is here. So if this was closer to the mid-Pacific Mountains and was basically elongated the section as this was forming as a backstop for this, down the mid-Pacific Mountains down here, maybe it's not directly a backstop, maybe it's opening the space, but it seems like it was actually down there. So that parts of Shatsky Rise are where it was just showing. That then broke off in the process and went over to Wyoming, basically going this way. So this material that was blocking here, actually some of it went up to Wyoming. So that's the general concept here, that this was forming, and then atop that was Australia, which notice it's quite similar to Mariana Trench. Not saying that this is how it formed, but the current that formed the western, or the southern Australian margin here, when Australia was facing this way, basically, retained its nature to later form the Mariana Trench, is what I'm suggesting. This then has this like pointy side of New Guinea that wasn't actually formed yet, but the undercrust was formed as this pointy section that then had deposits put on it to make New Guinea pretty much as this process occurred. So this was generally like there, and it moved away. Possibly like right here is Ontong Java, and it's still kind of right there relative to Australia. So possibly it was like a hinge, and Australia was facing one way, and it just rotated relative to Ontong Java, possibly with some rotation of Ontong Java. Not sure if Ontong Java is thought to have rotated, possibly. Which is probably why Ontong Java shows very little subduction evidence as a soft collision, as they describe it, because it was basically there, but the evidence for subduction that is soft was from like this turning process and the interaction of the two regions that were not exactly one. So it rotates and moves away. So let's just rotate it, say, minus 90, where it's like, then Ontong Java is there. So it actually moves out and over like that. Okay, let's add some layers. Then I put in this one, which in the previous episode, I was talking about how I thought this section used to be more in line, which is over here, here, west of Shatsky Rise, where it goes up and then over sideways, where this section is in line with the path from what I call the mantle puncture hole. So this path is in line with this, which is generally in line with the Chinook plate lines, magnetic alignments, suggesting a through current was involved in both of them. So I'm looking at this stuff, and I found this rotated relative to this, so there's actually discussion of that. Oh, there's me looking at the fucking bullshit of the world. Let's go ahead and just close it. And posting on it. I believe it's this paper where M20, the magnetic alignment cron numbers, Mesozoic 21, Mesozoic 20, they're just continuous but rotated. And then in that region, Shatsky rise formed while this section rotated relative to this section is my interpretation. And there's kind of that they definitely describe rotation, so we can go like this. Rotate. Noted this event attributed to a slow rotation. Let's see what they're talking about before that. Most significant tectonic event indicated by the data was a reorientation of the spreading ridge. Implies that the spreading direction changed 24 degrees clockwise. Previously, a slow rotation. Let's just put in clockwise. And go to the first one. Pivoting 24 degrees clockwise from M21 to M19, which is when we were just looking at M21, M19, basically. As a more broad range. And then I believe there's another rotation from M11 to M10 changed plate reoriented plateau 15 degrees clockwise, so there's multiple for 40 degrees basically of clockwise rotation. So that essentially they were once more in line, is my interpretation. And in the over here, relative to Hesse-Rise, which is here, was Kamchatka. But I think it's worth noting, if I can find this, I'll pause again. Okay, I found it. So this is from Karen Sieglock's work in Nick Zentner's A to Z Alaska episode Z, Alaska's Big Z, where she showed this among other times, but this screenshot is from that. And I thought, what if Kamchatka is basically like here, and then Japan, relatively, like that region, was like there. And then like towards Taiwan, I guess. I don't know if this is fully matching the geology of those regions in terms of timing. So that in this region was the area that looks like this, and then turns and goes, turns, like they actually do more like that, and goes like this, and then basically Hesse-Rise is here, and Kamchatka, and gets shoved northward along what would become, let's do another color, the Emperor Trough, so that Kamchatka gets shoved up to, as well as Asia, which is behind Kamchatka, gets shoved up north to the end of the Emperor Trough, basically. And then it gets shoved out. So it slides out over there. And then the Emperor Trough, though, is out over there with the Chinook Trough. And the other thing there has rise. Has rise. There's another trough. I don't mean on the other thing as in has rise. I mean the other trough that I don't even know if it has a name. So that as this is happening, Kamchatka is basically squeezing against his back pressure behind these things that are getting shoved up here into it. And then they start to move around 100 million when the sphere of the Hawaiian sphere runs into Kamchatka. So it starts to move, but then the whole thing buckles as Kamchatka gets shoved out to the side, which is maybe more visible in this one. So I was thinking, if we do that here, if it's generally, say, against, if we go back here, like it's over, here's Kamchatka, and then here's Kamchatka, or that's going closer. Here's Kamchatka, about the same, a little further. There's Kamchatka, and then there's Kamchatka, like further away from North America. But over here, I was thinking it's kind of like along this area still. So that it's the buckling that's happening is kind of shoving it out. And I talked about this in the last one, but I still think that's quite related. Okay. So let's just keep going, because I want to get to the Chinook plate. What is this one? That's Australia. And then I was thinking maybe Japan. Like I said, Japan was here. So I put... Perhaps my thought was Japan relates to Shatsky Rise, where it's generally where Shatsky Rise, or Japan is generally, once was where Shatsky Rise is, so that there was rotation involving this underplate, but also Japan's moving outward to wherever exactly it is, like right there. Relative to this, slightly different angled. Here's Japan. Sorry, I really need to get a mouse pointer. I was looking at it the other day. Like, I think I can do this, but I never chose one because I just wanted like a yellow mark. Here's the rotation area. Here's Shatsky Rise area here in the lighter, basically where the lighter blue is without the magnetic anomaly so prevalent through it. Over here is the Chinook Trough, Emperor Trough, Hess Rise, and then this area up to here and down to the Mendocino Fracture Zone. This area is called the Chinook Plate, which we're going to get into because, whoa, dude. Let's just keep going, though. Then I put in India under the thought, well, maybe, let's put some more in. Like beyond this stuff happening was Borneo getting shoved ahead of this. Like beyond here was Borneo getting shoved ahead as an arc. The whole structure, a current was flowing into resistance at India, and that flow basically shifted eastward around the pressure at India to then go south to elongate the current that was flowing into what would become the Indonesian archipelago, and but then shifted off of it and the earth expanded. So but it started more over here was what I was thinking. So if we put in Australia again, like this corner of Australia is basically in like there-ish. It's hard to do it exactly. And then the Philippines were actually turned this way relative to Borneo. Kind of weird with the Japan thing there. It's still definitely complex. And then I tried to put Antarctica in its general position as well, just to note it. So all this stuff is relatively proximal. And very distal now. And if we look at some papers. So what is this one? Not sure why I put this one at the front. Resurrection plate. Okay. Let's just note it. And this one I've been thinking about. Rhea, and Dixon, late Cretaceous and Paleogene tectonic evolution of the North Pacific Ocean. Late Cretaceous, and they say from 82 million to 50 million, this configuration was stable. The Chinook plate expanded. The Chinook Kula Ridge migrated north, and the Kula plate was subducted. With subduction of this ridge, the Chinook plate adhered to the Pacific plate, and the Pacific Farallon Ridge became the north-south trending feature reflected by anomalies 22 and younger. Okay. And we've talked about this, but let's go back to it. I want to get the image. I'm sure there's good information in here, but the images are so good. So they're saying that Shatsky Rise is over here on the Pacific, and then Hess Rise starts to form around 105 when the Mendocino fracture zone is really starting to shift as this focal point is shifting away. So this bottom section is shifting eastward, shifting. And then while that's happening, at around 83 million years to 82, the Chinook plate appears. Down seemingly here, I'm not sure how the Kula, I guess the Kula is the Farallon breaking from the process. But the Chinook plate starts to form here, like it didn't exist yet. And then it starts to form, as they say, expand. The Chinook plate expanded. It grew there, expanded. Dudes, the Chinook plate expanded, but the Earth didn't. But if we go 82 to, say, 57, then we've got the Chinook extending up to pretty much what would end up subducting under the Aleutian arc and not be visible. So the Kula plate's gone. Anything that we call Kula plate here is just subducted. All we see is Chinook plate, which started to form around the time the Hawaiian Emperor seamounts visibly formed. What we see is around this time in terms of the Oldest seamount. Oldest twin emperor seamount. Da-da. Meiji, approximately 82. Let's see. We can just say Meiji seamount age. Let's say 192. This is possibly saying 75. Let's just do Meiji. See if it actually maybe say even just straight up 82. I'm a little confused. Where is Meiji? Previous limited to potassium argon. Argon ages of dredge samples from several volcanoes and core samples from Meiji Seamount, figure 3, or table 3. And, was it figure 3? Oh, Detroit. Coco. Meiji. That's very odd. It's saying like 35 there? What? No. Here we go. What is this? Age, distance from relationship. Meiji, even that's around 70 on here. Detroit, North 80. Is Meiji the top one or Detroit? Or even, I feel like there's a Russia name, like a Russian named one. Emperor Seamounts. Yeah, that's generally what I've seen before. Like that. Detroit 81 to 76. Meiji greater than 81. Point is, around the time the Emperor Seamount chain happens to be the oldest one subducting, the Chinook plate began to form. Okay, so let's go back to Chinook plate though, because I really want to, like, dudes, look at this. It starts at the Mendocino fracture zone, goes up along the Emperor Trough, and then basically all the way up to even beyond the Emperor Trough here, but generally to the Emperor Trough here. Like, let's go from here. Like if we did this, go, say here, And here's Hess Rise in the upper trough, but nothing's there yet. 83 million. Kamchatka's still over here. And then the Chinook plate starts to form as this moves northward along the Emperor Trough direction. And then this area becomes like this, so that it's expanded it. It starts like this, becomes like this, where it expands it and shoves it up. And then this stuff start over here, next to the Chinook, not this Farallon, but east of the Chinook. This region, or sorry, here the Chinook basically goes to right here. This where it bends left. Chinook plate is generally to like Sand Point, maybe even. Sand Point is right about here where those earthquakes were happening, I believe. Maybe here, somewhere around here. Somewhere around here is where those earthquakes were happening at Sand Point. Right before the Kamchatka, not 8.8. But then the Chinook plate forms, and then over here forms. So if we imagine this forms, shoving Kamchatka up, and then this forms, squeezing in between North America and the Western Pacific, shoving it west, even though it's like going up, so that like, let's say this one, so we got it. Hess Rise over here. And then Kamchatka getting shoved up along the Emperor Trough to its present position up here. While this region expands, forms, where along the process it has the Chinook Trough form, and the Emperor Trough is there. But then, after it's moved Kamchatka up, this area actually wedges through currents that cause additional dextral slip generally, like the Yakutat terrain, but ultimately are spacing North America and the Chinook Trough apart, which is not just the Chinook Trough, it's everything past it. So Pacific Plate, Western Pacific, Asia, Kamchatka. And this stuff is being pushed westward by this forming as the space opens. And there's just no need for anything else, I don't think. Like the stuff going on up over here in the Pacific is driving dextral slip. Simple as that. That was occurring along Western North America, especially from the Mendocino fracture zone northward. Boom. That shit is fire, bro. Let's look at it. Let's look at some more details. 83 to 50. So let's say that this is happening, where the Chinook is forming, and it's, or suppose, what do you mean to say? It's not happening. Shut up. Anyway, let's suppose it's happening. So what happens at 50 million? Well, the Chinook plate stops forming. That's a little odd. I wonder if anything else happens at 50 million. Oh, yeah. Over here. Scholar, so let's see a eruption. Let's say, I don't know. Geological history of Silesia. 56 to 49. Accretion completed between 51 and 49. So imagine Western or Eastern North Pacific, this region is not yet formed because it's still back in the time of Chinook plate time. And as this is forming from bottom up, it suggests bottom up pressures, flows, undercurrents of the process going south to north. So when they literally can't, because it's not able to form any, it's not able to like squeeze more in, it then just erupts at a weak point, which my thought is the Chinook trough. Eruptions start to happen here, which is really over here in this area has Silesia, but maybe like off the coast somewhat, or like partially somewhere generally over there. While it's spreading away, these eruptions are happening until it literally can't do anything else, and wedges them apart so that this area can form, because this is being prevented until they separate. Like nothing can squeeze in there. Something needed to give. The planet broke, essentially, its structure, and gave way for new crust to form in between North America and the Chinook plate. And then it flows in, but not before creating Silesia. Tying Silesia to the Chinook plate, to the Chinook trough, which points at the region of Silesia as well as Yellowstone over here and Bighorn Mountain there, generally speaking. I know it kind of points at a broad area, so it could be argued it points maybe like down here too or up here too. In terms of like a broad pointing, because it's not really a straight line so much as a bunch of like angled cracks. But if we go from here, where the straight line of the Emperor Trough reaches the bend, and just go along that way, it does point at, if we go here and just go to Yellowstone, I know I'm like forcing it. It points through this area to Yellowstone, and generally along it, definitely is a matter of where you choose over here. It's kind of where the straight line ends is pretty much a perfect fit, oddly, rather than where the bend begins. And then it even goes relatively through Orofino, which is there. Why did that measurement go away? Orofino there. So if we go back, go to generally the bottom of that again, and to Yellowstone, which I'm just going to the lake. Maybe I should go here or something. Very near Orofino. Like if I do go to like the center of that, like here, Still not to Orofino. More through this and or towards Orofino, though. I feel like the lake is a good point, though. Like it's where the pressure point was, kind of. So my thought is, and then at 70 million, the Carmax group was forming in relationship to the Chinook Trough. So if again we go over here, Chinook Trough is showing up around 72, 82. It's not there. They label it. I guess they do label it there. But its actual, like, ramifications, I guess, are more visible at 72 and beyond, where it's starting to actually spread away from this and not just be the same location. Which is arguably more so this location that they have labeled Chinook Trough that has then moved away as the trough formed down here. I don't know exactly why they label it Chinook Trough at that moment, but the actual manifestation of the trough, I guess because it reaches the corner of the straight portion of the Emperor Trough where the bend begins. That's probably why, because it was propagating north to there. Okay. Then I came across this paper, and I don't know what I was exactly thinking. Oh yeah, this. This is also by Rhea and Duncan, 1986. North Pacific Plate Convergence, a quantitative record of the past 140 million years. Notice Kamchatka all the way over here. Or not Japan, sorry. Kamchatka. All the way over here. Not even like remotely related. Here's Chinook forming. Not yet formed Hesperise, Shatsky Rise. And this top one. Shatsky Rise, Hesperise. This bend going on. And then a bunch of who knows what question marks because it's kind of in subducted areas. And then Chinook Trough is forming, or Plate is forming on Trough, but Plate. Maiji's all the way down here. So this is then shoving northward. This whole area is extending, and it even seems related to the formation of the Emperor Hawaiian seamounts. And then it even points at Kamchatka, not just at Kamchatka, but at the frickin' nook in Kamchatka. At 30 million. And then they've split so much that the path that was over here is over here. See that? It starts going by Chinook at 100 million. And then at 70 million, it's moving eastward relative to Chinook. And then by 30 million, it's over here. When the reality is, it was always over here. It was maybe at depth, so that it was happening in these materials that then shifted away. And then as time passed, as things shifted away, the same undercurrent that was over here that was shaping this region of oceanic crust that was actually over there, that slid away, that same region was being exposed to the same general currents, even though the layers that were previously exposed to it have shifted away, so that they're over here bearing all of the evidences of their relationship to what's going on the east coast or west coast of North America. And wholly gone from over here, so it looks unrelated. I mean, to me, this is conclusive evidence. Some of the most conclusive evidence I've ever seen with Chinook plate. I would say nail in the coffin, if there weren't already so many nails in the coffin. That actually is worth just switching gears entirely. I was looking over here. Stuff about Kerguelen Plateau here is really interesting. Because this was over here, so let's find some of these papers. Might be over here at the end. I really think I'll put it forward though. This is actually interesting. Asynchronous bends in the Pacific Seamount Trails. The Gilbert Ridge and Tokelau seamounts are the only seamount trails in the Pacific Ocean with a sharp 60-degree bend similar to Hawaiian Emperor Bend. These two bends should be coeval with the 47 million year old Hawaiian Emperor Bend if they were formed by stationary hotspots or just really blah blah blah, and assuming Pacific Plate motion only. New argon ages indicate that the bends of the Gilbert Ridge and the Tokelau Seamount Trail were formed much earlier than the Hawaiian Emperor Bend at 67 and 57 million years ago, respectively. Such asynchronous bends cannot be reconciled with the stationary hotspot paradigm, possibly suggesting hotspot motion or magmatism caused by short-term local lithospheric extension. And then here's the Gilbert and Tokelau, and then they also have Louisville. Interesting time frames. But then the bends do not match. 47 for Hawaiian Emperor Bend, 57 for Tokelau, 67 for Gilbert, and 46 for Louisville. Just like, how the fuck does plate tectonics even persist in this? It just inserts hotspots to explain every anomaly and ignores all of them. We got it. It's hotspots. Well, they're Wait, they're not stationary. Okay, well, I guess they're moving sometimes. So they're hotspots that can move sometimes when necessary to explain the data. And any other questions? Put the checks in the bin. I appreciate the donations. We're really too good. I know. Just keep on supporting us, guys. Okay. Great Alaskan Terrain Wreck, Stephen Johnston. So again, just kind of pooping out Kamchatka. That's his image that we saw earlier. Okay. Trying to find Tethys going down to Indonesia through basically into the Himalayan region prior to Himalayas, but because just like in the Western Pacific, how the currents were once flowing into the Western Pacific, in spite of being shifted away off of out from under North America, where the undercurrents still persist at North America. In this case, Indonesia shifted off of Asia generally, away from Asia. I mean, not off, but away from this area by the Tethys shoving across, undercurrents flowing through here, cutting through, shoving Indonesia and Australia and North America away from Asia, where Australia and Indonesia were still more coupled to Asia than North America, so they separated as well, kind of like how the Chinook plate remained more coupled to the Pacific plate than to North America, so it moved with the Western Pacific and became part of the Western Pacific. Okay, I'm really a little confused. I could have sworn I had like Kerguelen papers open. Let's just look some stuff up. Something like this. I don't know. Maybe look at something a little more recent. Just not sure we can look at this. Cool. Records for a long-living composite microcontinent. I know it started. Here we go. Basalt from Kerguelen, 118 to 68 million. Very similar to Ontong Java. From, at least in terms of the beginning, from India, 118 Rajmahal Trap and Eastern Ghats. And the Lamprey fires in Antarctica 115 are assumed to share a common origin and derive from the same plume because of similarities in age and magmatic properties. Interpretation of the Kerguelen Plateau as a continental plateau differing from classical large igneous provinces, was first mentioned where it's continental, so it has continental crust. Whether Kerguelen was a continental fragment or oceanic island, in the 80s, most of the publications concluded to an oceanic setting under the influence of a Kerguelen hotspot. More recently, however, several evidences supported that part of the plateau was composed of continental crust and that Ellen Bank could be a microcontinent separated from Asia during its split from Antarctica due to a ridge jump younger than 124 million. So my thought is, mind you, so in India separated, if we go, like, follow this line over here to there, if we follow the far one, there's a line going across, it goes to exactly here. So Kerguelen was exactly here relatively before this space opened. It was over here, forming at around 118 million and afterwards. But if we follow the 90 East Ridge, I believe, 90 East Ridge geology, it formed north to south Alright, some dates. Formed ages of basalts from drilled holes form a linear succession. The available 7 points are insufficient for discovery of the assumed reverse age trends in the southern part, which follow from the analysis. Let's see what we can find. Here we go. 77, 73, 68, 63, 62, down to 43. So from about the time the Hawaiian Emperor Seamount chain starts to form to about the time of the bend, Kerguelen is getting shoved away as this is forming from India. It's not that India is moving away. It's that the Earth is expanding, and pressures that were flowing into Kerguelen when it was up here shifted over, and it shifted as the Earth expanded because it was more coupled to Antarctica than to India ultimately. And its microcontinental fragments are mighty similar to what I've said is generally going on here, where there's this stuff is moved away, but it's kind of like forming too, so that it makes sense. Like if you kind of just say like, well, maybe it's from up here. That some of the components are missing because they're over here. It just makes sense. So it fits in with the Indonesia stuff. Moving away, where it moved out and then down, but it just moved more down. And in this case, it didn't move out. It just moved down, even though it ultimately moved down over here and out this way. So it kind of moved west also, maybe. But I'm thinking it was more like over here. In this area, maybe even related to Tarim Basin ultimately. But forming generally over here when Indonesia moved out and down, and then this decoupled from Indonesia. In this time frame. And then there's the naturalist plateau formed early Cretaceous, which is another thing. The ages, if we find Kerguelen again. Maybe there's a map with the ages. I don't see any ages on it. It might say ages, but I don't feel like actually looking. If it's not on the image. I know I've seen it on the image. Let's try this one. No. Maybe that one. Probably not this one either. It's a little old. Newer one's more likely to have the one I'm looking for. Maybe that one? Time frame, construction. That sounds pretty good. Oh my god. Cough. Oh my god. Dudes. Okay, we're back. Back with Duncan's time frame for construction of the Kerguelen Plateau and Broken Ridge. Broken Ridge over here. 95. Naturalist Plateau, which I casually looked up here. 136. So the point is I believe what's generally happening is there's a younging north to south, where the oldest is at the north in the 90 East Ridge, and then a younging east to west in the Naturalist Plateau, Broken Ridge. So it's like separating from Australia also, which would explain it moving like this way and having those lines be more this way than just straight down. It's separating. But then 118, 108, 100, 68, 34. General younging this way. There's definitely some nuance that this doesn't capture that I've seen different. Like, it doesn't just young that way. There's definitely more to it than that, but a general trend, general trend, general trend. So there's this motion of how things are happening. It's not just sitting there happening and from like one focal point it's moving relative to other things, because essentially the energies are escaping at some weak point, but then when it does that it adds energy pressure to that weak point. It seals it off so that a better exhaust point further away down some direction is just a better place for the energy to release. So it propagates, it doesn't just sit there. As part of the process of how this all happened when the flood occurred and the earth expanded. What? Yeah, I don't know if I mentioned that part. Hopefully, if you made it this far, that doesn't surprise you. Where Australia moved down from here. So I think between the Chinook plate, stuff going on over here that I probably need to do some more episodes on really getting into, admittedly, are quite good evidences. Oh shit. Okay guys, I'm just gonna cut this here, I guess. I'll be back. I've been looking at so much stuff and like, I'm sure I didn't say everything that came to mind. I watched my last one several times now, and I've had several thoughts, and I definitely do not remember them. Sometimes I'm like laying in bed, and it's like so crucial that I get out of bed and write it down, or something. I've done that in the past because I was losing things. I lost something that came to mind the other night that was like, ooh, ooh, that really fucking made sense. And it's gone. Oh, wait, I can actually not stop here. Pardon me. Let's check out this thread on earthquakes. This is not very important, this one. I just thought interesting. It looks kind of like a cross. Maybe something would happen more there that's of higher magnitude some reason. I don't know. Just a thought. Outlier at Kamchatka on the 25th. That was just further out than all these other ones. And then here's that other outlier I've talked about before. It seems to have filled into it, but it still is kind of like a chakra there, which is actually right there. So it's not on the rotating plate, it's on the like fill-in space between the Chinook and the Pacific plate that pre-existed the Chinook. And then there was this earthquake, 0.2 kilometers in South Carolina depth. What the fuck? 3.0, no one felt it, I guess. I don't know. For 0.2 kilometers. I don't know if that's I just don't know what to make of it. Here's one at 3 kilometers, Nebraska. And then there was more than one. There was, I believe, 3 of them, 5 and 5.5 kilometers in that area. Which then, if we look at the Mendocino fracture zone, I mean, it generally goes there. Valmy is generally along it. This is down here away from it. And just the stuff going through here that goes across that way. If we look at the like mouth, like a nose and a mouth, that's a breathing fire kind of thing over here. It then has another mouth here. My thought was currents generally go through here, they'd cut through here, through this mouth, and maybe some of them are cutting more across the mouth this way, which then those earthquakes are like over here somewhere. Can kind of see the mouth. There's the nose and the mouth generally there. It seems related. And then there's this one, this map, which I'm like, this just looks like an arrow right here. The straight down segment, and then like going over this way and going generally any of the ways over here. Just it made me think of an arrow, and so I drew some lines. And if we imagine a current is exhausting from the Arctic through various pathways, one of which is along the margin of North America, another of which is along the Mariana Trench, but then there's currents from north of it, between Antarctica and Australia, especially over here, that go this way, applying a pressure so that these currents are colliding over here more so in that particular path, which I even drew as like a branch off here that goes down through here and across into this area to go up, generally towards Kamchatka and along Mariana Trench region and across through the Kermadec Trench to the point in Alaska and across Zealandia's margin to the area over there as like pressure points, as well as flowing through here and going up that way. Where then currents are just flowing, so if we imagine Gackle Ridge has a flow that's going this way, running into resistance of currents in the Pacific region underneath it, and bending off and going either south or east. If it goes south, it can flow in an eddy here. That then, my thought is, if it reaches here, it has a good chance to actually go this way and go back up to Gackle Ridge and around and just kind of cycle in that segment. And if it goes eastward, it goes atop the pressure of the Pacific through that area, and then once it passes it, it flows down as like a portion of the arrow. So my thought is there's an arrow happening because the pressures are getting so much over here that they're actually going over more and down more to really use North America as a avenue to exhaust pressures from the Arctic into the rest of the crust, below the rest of the crust, where it's then flowing down through here, but it's like unabatedly flowing, where there's not much resistance in the magnetic anomalies. So it's like flowing into this area and then fanning out over here, as well as going along here and just being trapped. So there's more likely earthquakes here that are happening, some of which is getting through into the Caribbean, is my thought. So it's flowing through also, possibly largely along this path. Almost like a canyon where flows are reaching the canyon and then flowing along the canyon, but they're kind of being directed some into this area, but some up, exhausting out into the Caribbean, where then they flow across to Africa, that if they get through, so that like it's happening here. So there's an earthquake there. They're also running into that eddy current. Some of it's branching off as more southward and going across this way, and maybe even generally relating to this side of this arrow to like hold pressure here. I definitely didn't draw every detail. It was getting kind of covered in detail, so so it kind of makes sense, though, that there'd be a quake there, and then going down, that there'd be a quake there, where my thought is this red current starts out over here, but it actually goes to this side, where the green current starts out over here, but it goes to South America. So it's actually, even though when I draw it here, related to this side, going down also along this side as the green one, because they're flowing in different directions. So their pressure points are going to be separated where there's a gap between them that the ocean is forming. And basically, as they push the continents apart so that upwelling can happen along that gap and new crust be formed. So I was thinking, well, maybe this arrow suggests actually there's pressure being forced over here. There was actually an earthquake over here that made me say maybe it's even being pushed even further. And if we look at the earthquakes in the last day, that's that one. We have had a 6.0 maybe at the Mariana Trench here, and then several more over here. These are actually just changing the angles. They were going this way, now they're going this way. They were, it rotated. Wow. So it's also possible that it's like exhausting this way through that arrow-like shape that then runs into a counter pressure, which is creating earthquakes over here, and there's other, it's flowing up here, that it's interacting here as well. This almost looks like the freaking trident. Oh, damn, dude. Got some explosions, though. These are dynamite. Or something. That's weird. We see explosions there, but nothing over here. I just don't depict them. Like, what the fuck? Fucking everyone's a simp for genocide, huh? We're just being apolitical. There's no fucking evil or good. There's no fucking middle ground. Okay. And then I was looking at shallograms. This one's actually, I won't talk about it now. It's too different subject. I thought this was oddly similar to this. Zealandia down here, Fiji, Solomon Islands, Philippine Sea Plate, and then Java, Sumatra, Indonesia. Oddly familiar to this. Oddly. Okay, dudes. Time for revolution. Don't you know? Talking about a revolution. Sounds like a whisper. He's so fucking lame. Fuck that dude. Bruh. Fuck that dude.